Ladies and gentlemen, it gives me immense pleasure to welcome you all to this thematic session on reducing plastic and chemical waste in marine environment as a part of World Sustainable Summit, the annual flagship event organized by TERI. The summit series has a legacy of over 2 decades for making sustainable development a global shared goal. The only independently convened international summit on sustainable development and environment based in the global south, WDS strives to provide the long-term solution for the benefit of global communities by assembling global thought leaders and thinkers on a single platform. The theme of this year's WSDS is Leadership for Sustainable Development and Climate Justice. Today's thematic track event is focused on plastic and chemical pollution in marine environment. This is a topic of global concern as it possesses a serious hazard to the environment and human health and therefore hinders the achieving several of the sustainable development goals, particularly in developing countries. Pollution due to mismanagement of plastic waste and hazardous chemical is a global threat. The objective of this thematic tract is to share and build knowledge and capacities to tackle plastic and chemical pollution, to identify solutions towards reducing plastic and chemical waste. Today, we have with us a very special guest, Ms. Martin Botham, the Deputy Ambassador of Norway to India. We welcome you, ma'am. With the experience in international affairs, a dedication to teamwork, she works hard to improve relationship between Norway and India. Her diplomatic work helps both countries understand each other better and work together on a common issue. Ma'am, we're glad to have you here amongst us. And on behalf of the August gathering, I invite you to deliver the welcome remark.
Friends and colleagues, thank you to MGC and to NIVA for inviting me to this event today. I'm really proud to see that the cooperation between India and Norway shows solid results. It has been 4 years since our countries agreed to set up a marine pollution initiative. This initiative, the Marine Pollution Initiative, is part of the Blue Economy cooperation between India and Norway. And we enjoy strong and close collaborations that we continue to develop and strengthen. Both countries are also engaged closely in respect of multilateral environmental agreements and processes. And of particular importance to our topic today is, of course, the Intergovernmental Negotiation Committee, INC, on ending plastic pollution. In March 2022, at the UN Environment Assembly, a historic resolution was adopted to develop an internationally legally binding instrument on plastic pollution, including in the marine environment. Norway is a champion of this instrument, and we are very happy about our important discussions with India in relation to this process. You may know that Norway and India have an excellent cooperation, not only in the area of blue economy, but also in circular economy, renewables, food security, research, and higher education. Plastic waste is a challenge to the environment if not properly collected. The chemicals in plastic pose a severe challenge as it leads to consequences to the marine life and to humans. And quantities of waste, particularly plastic waste, are growing in both Norway and India and across the world due to economic growth and rising consumption. From the 1st of January last year, all organic waste and plastic packaging must be segregated by source in Norway. The main reason for this is to increase the recycling rate. Norway is committed to the EU targets on recycling, which states that 50% of all plastic packaging shall be recycled in 2025 and 55% in 2030. But for many reasons, plastic recycling is challenging. However, I want to highlight one success story within recycling: the deposit return scheme for beverage containers like cans and plastic bottles in Norway. This deposit return system is one of the most efficient in the world. The return rates last year were 91.5% of the cans and almost 93% of plastic bottles. And the inventors of the reverse vending machine that are used for the collection, TOMRA, they are established in India and they are working towards a circular economy also here. Earlier this week, I had the pleasure of joining the launch of the book The book integrates in one system all relevant research in monitoring, detecting, and control, and provides a multi-barrier approach to managing EDCs that helps relevant stakeholders take preventive measures for the risk associated with these chemicals in the environment. The book was produced with support from Norway. And today I am delighted to attend the launch of the book titled Managing Persistent Organic Pollutants in India, Case Studies on Vaipi and Surat, Gujarat. This book presents some of the results from the first phase of the project supported by the Norwegian Embassy, the INOPOL project. The book focuses on determining the source, fate, analytical techniques of detecting POPs, as well as their health impacts. It dwells on the regulatory aspects, management of POPs, best environmental practices, Indian and international case studies, gaps in the understanding of the regulatory aspects, and elaborates on a case study of Gujarat. The second phase of the INOPOL project is now building on the established and well-functioning partnership in the Norway-India cooperation project. This phase aims to support the reduction of plastic pollution and POPs in India. The project will contribute to science-based solutions to manage POPs and plastic waste and ultimately help protect the environment from the hazardous impacts of such pollution. I'm looking forward to following the progress in the INOPOL project. It is a fact that we need more data to prevent, manage, and tackle plastic and marine litter. Research and data collection allow us to quantify the extent of plastic pollution, both on land and in our oceans. By analyzing data, we can identify the hotspot of pollution, track trends over time, and comprehend the full scale of the issue. Research helps us pinpoint the primary sources of plastic pollution, whether it is from improper waste management, industrial processes, or other factors. By understanding how plastic enters the environment, we can implement targeted strategies to reduce these inputs. Data-driven research allows us to assess the environmental impacts of plastic pollution on ecosystems, wildlife, and human health. By studying these impacts, we can raise awareness, advocate for policy changes, and prioritize interventions to mitigate harm. The work done by our partners, both in Norway and in India, is an important contribution to building a knowledge-based research foundation. The hope is that this knowledge will inform policy decisions in India and globally, and hopefully contribute to finding common solutions to this global challenge. Today, I'm looking forward to the discussions and to learning more about how science-based policy can support the reduction of plastic and chemical pollution, and particularly to see how lessons from the global research landscape can be applicable in the Indian context. The launch of the book today is indeed a tangible result. Knowledge sharing and capacity building is an important part of the Norway-India cooperation, and today's event is an excellent example on how we can use the outcome of projects for a common good. I also wish to take this opportunity to encourage you all to join the session that starts at 4 p.m. today in Silver Oak 1 on challenges and solutions for reducing marine plastic pollution. The session is organized by UNEP, one of the embassy's partners, under the Marine Pollution Initiative. Hope to see you there as well. I wish you a good session, and thank you so much for the attention. Namaste.
Thank you, Your Excellency, for your insightful address. Your leadership and guidance will give us impetus to endeavor the mitigation pollution in the marine environment. Now, we are excited to have with us Dr. Mariana Oslin, Research Director, Norwegian Institute of Water Research, joining us from Norway. Her research interest includes ecology, marine biology, contaminants, ecotoxicology, sediment remediation. She has done her PhD from University College of Southeast Norway at the intersection of marine ecology and ecotoxicology. Ma'am, we are glad to have you amongst us. I welcome you to deliver the keynote address. Ma'am, over to you.
Thank you so much. Am I audible?
Yes, ma'am.
Good. So thank you, Your Excellency, Mrs. Ambassador, project partners and colleagues, friends of India and Norway, and participants gathered today for fruitful deliberations around the important topics addressed in this thematic track. I am honored to welcome you all to this event under the World Sustainable Development Summit of 2024, addressing plastic and chemical waste in the marine environment. And I apologize for not being present in person at the India Habitat Center with you today, but luckily I have many good colleagues from Norway and India on site. Coming together to discuss and join forces are more important than ever as the world is facing more major environmental challenges on a global scale. Across the globe, we are seeing the effects of biodiversity loss, climate changes, and pollution. I believe that we are all aware of the magnitude of chemical and plastic pollution, and that we share the same concern and are eager to contribute to find solutions to the challenges we face. Chemical pollution isn't always so tangible, though the ubiquitous and very visible presence of plastic pollution has boosted the awareness of the adverse effects of our consumption of plastic products across nations, and new knowledge on the impacts and effects of pollution is built every day. We are experiencing an unprecedented global political will to find solutions to reduce plastic pollution and to develop regulatory initiatives at national and international levels. In March 2022, as already mentioned, the world's nations met at the United Nations Environment Assembly in Nairobi and agreed to start negotiations on an international legally binding instrument on plastic pollution. Already 3 sessions of the Intergovernmental Negotiating Committee has been finalized, the first in Uruguay already in 2022, and the second and third in Paris and Nairobi last year. Later this year, the 4th and 5th sessions will continue in Canada and in Korea. Though there are many obstacles on the way towards a global agreement, the negotiations clearly demonstrates that only by coming together and joining forces across nations can we solve the global challenge of plastic pollution that we face. With a predicted increase in the production and consumption of both plastics and chemicals, both expected to double within the next 20 to 30 years, we have a tremendous challenge in front of us. A holistic perspective to the problem will be crucial to find sustainable solutions working together across interests involving multiple stakeholders with a life cycle perspective. I believe we all know this. Still, the actions needed are not clear to us, and there are certainly no quick fix to this problem. Moving back is not an option. We need to find solutions that are feasible and compatible with the times we live in. We cannot alone clean ourselves out of the litter problem, though beach cleanings are important activities that contribute to local improvements and to awareness raising. Neither can we solve the problem solely by replacing plastics with other materials, though using the right material for the right purpose will be a part of it. Nor can we recycle ourselves out of the enormous amounts of waste produced during the last decades and that still are to be produced, though life cycle and circular perspectives will have to be a part of the solution as well. A holistic approach will have to include many different mitigation actions involving multiple actors and stakeholders, from the producers to the consumers, and on to the informal sector of waste pickers and other actors in the recycling sector. There will have to be changes and improvements to everything from raw material production, product design, waste management, and consumer habits. For all this, we will need more knowledge, and we need to make sure that the knowledge is made available for policy and for decision-making. Efforts to reduce plastic leakage from the countries that represents the largest discharges will also make the largest impact on the amount of mismanaged waste, of marine littering, of microplastic pollution, and of threats caused by chemicals. India, with its enormous population, have a major role to play in this regard. As the problems are large, the potential for making a difference that actually counts is also large. Effective measures on chemical and plastic pollution in India have a great potential for reducing the chemical and plastic pollution input, not only on a local and regional scale, but also globally. Norway is a small country compared to India. Though, like India, we are a nation with large marine areas to manage, and there is a strong bilateral oceans cooperation between India and Norway. The India-Norway cooperation project on capacity building for reducing plastic and chemical pollution in India, known as INOPOL, is developed within the India-Norway Marine Pollution Initiative under the Task Force on Blue Economy. Allow me at this stage briefly to introduce our institute, the Norwegian Institute for Water Research, NIVA. NIVA is Norway's leading environmental research institute for aquatic environment, established in the 1950s. We have 450 employees from more than 40 nationalities, working within multiple fields of natural and social sciences related to the aquatic environment, covering all kinds of pollution, biodiversity, climate change, and other environmental challenges. We work closely with the public and the private sector to transfer our research and knowledge into action and policy at all scales. Our involvement in India spans more than a decade back, and I would like to acknowledge Dr. Girija Bharat at Mugama Consultant for initiating a long and fruitful collaboration. The INOPOL project has been an Indo-Norwegian bilateral project since 2019, which aims at reducing marine litter through a river catchment approach, paying attention to the sources and the riverine transport from land to the ocean, as well as the societal processes leading to waste astray. In addition, the linkage between plastics and persistent organic pollutants, the POPs, are made clear as the project also builds capacity and produces knowledge on chemical pollution. With support from the Norwegian Embassy to India, NIVA, together with Indian partners Mugama, CPET, Toxics, Link, and SRM, will continue building knowledge and capacity to tackle plastic and chemical pollution, in trust that our joint effort puts down new pieces in the puzzle and brings India and the world new steps forward in the right direction. The pillars of the INOPOL project are to map and monitor pollution and sources, include building models for estimating riverine transport of litter from land to sea, and to assess the effect of mitigation measures. It is also to carry out policy analysis and to investigate the social dimensions, including the role of the informal sector, and to assess opportunities and obstacles for a just and sustainable transition. The entire project is structured around technical training, co-production of data, and capacity building. The project also contributes to awareness raising and produces material for various stakeholders, spanning from scientific publications, which are important to build policy on credible, relevant, and legitimate data, to policy briefs and popular science publications. As one example, the POPs action plan for Gujarat was developed during the first phase of the project to support the implementation of the Stockholm Convention in India. The report also discusses the potential important interlinkages between PAPs and plastics from different waste streams in India and provides recommendations to eliminate the presence of PAPs in the environment and avoid giving rise to toxic byproducts. Further, the report emphasizes the importance of eliminating the use of PAPs and other hazardous chemicals in plastic production and products, thereby avoiding the recycling of such substances in plastic waste, facilitating new market opportunities and the circular economy with safe feedstocks of recycled material. The proposed actions in the mentioned report are directly linked to the goals and the strategies of the Basel Convention, Rotterdam Convention, and Stockholm Convention, and will make contributions towards achieving the UN Sustainable Development Goals. The results of findings from INOPOL not only have fed and will continue to feed into policy development in India, but are also feeding into the international negotiations for a global treaty on plastic pollution. NIVA is committed to continue the collaboration towards the successful implementation of the project in different geographic areas of India. I would like to take this opportunity to acknowledge our excellent Indian partners. And finally, I would like to express my votes of thanks to the Norwegian Embassy, as well as to the Ministry of Environment, Forestry and Climate Change for their crucial and valuable support in the INOPOL project. And with these remarks, I would like to welcome all of you to fruitful deliberations. Have a nice day, and thank you for your attention.
Thank you, ma'am, for your perspective on this very important issue. Now, I would like to take this opportunity to introduce you to the INOPOL project, which is a collaborative project between NIVA, Mu Gamma, SRM Institute of Science and Technology, CIPET, and Toxic Link. To tell you more about this project, I invite Dr. Hans Nicolai Adam, the Senior Research Scientist of NIVA, who is a PhD in Development Studies from Norwegian University of Life Sciences. Presently, he is working as a senior research at the intersection of international environment and development with NIVA. Dr. Hans, over to you.
Thank you so much, Kriti. Yes, my name is Dr. Hans Nicolai Adam, and I've been working with this project, in fact, for the last 5 years. So it's a little bit of a landmark to stand here and also to interact with all of the honored guests, to also talk a little bit more about the plans of INOPOL 2, and to also give you some more information of our approach and what we are planning to do. And I first wanted to thank the Norwegian Embassy for supporting steadfastly this project and this joint collaboration over several years and very actively. And I think your presence here itself shows this kind of support. I also wanted to thank Dr. Girija, who has been heading the India component of this project very efficiently for the last many years. And also our partners from SRM University, Professor Paramita, from Toxics Link, Satish and Piyush, as well as CIPET, who could not be here today physically. And in fact, this is the first time I'm here physically at the WSDS. So it's very nice to actually interact with you in person. And Her Excellency, you gave a very good introduction actually of the project already. So I will try not to repeat myself. And similarly for Dr. Marianne, you gave a very good overview of the project. But I'll try to emphasize maybe also some different aspects of the approach of the project. Yes, so as Marianne just mentioned earlier, this project has been running from 2019. And it actually has been running quite efficiently even during the COVID period. And now we are entering a second phase, which is going to work in Tamil Nadu. Now, why do we need this project? One of the key issues that was also discussed in earlier seminars, including on Monday, is that we talk a lot about quantities, we talk a lot about data. But when you actually look at the scientific literature, there's often a recoding of data. Let's say if you have an academic article from 2022, which refers back to 2017, which refers back to 2010. And this includes also data from many of the pollution control boards. We actually don't know the scale and scope of the problem in detail, in the sense that it's rough estimates of quantities that are released into the environment. So there's a great need actually to develop better systems, and in this case for INOPOL, coherent systems for data collection and analysis. And this is very, very important. For instance, there's been a great interest in modeling exercises over recent years. But what do models use? Models use assumptions. Models use time series data. But of course, if that data is not correct or incorrect, the kind of recommendations that come from there might not be very accurate itself. And I think this is kind of a first motivation for having a project like this, working with Indian stakeholders in a direct fashion to collect this data and to systematize processes around it. And this is true for both macroplastics, microplastics, POPs, as well as the social science data, for instance, with the informal sector. And what does it mean having this multidisciplinary approach? So if you look at, for instance, a very simplified river catchment model on the right-hand side, you can see there's many different aspects which are involved when it comes to assessing pollution and drawing conclusions and policy from it. So there might be hotspots, for instance, around industrial areas, urban areas, but also intensely farmed areas. They might have certain levels of pollution. There's modeling aspects involved. There's social dynamics involved. There's different sources, which we also have to identify. And I'm very proud to say that this team and this project is very, very multidisciplinary. We have geographers, physical geographers, human geographers. We have environmental chemists. We have modelers, and all of them are working together on a joint approach. So while there's a lot of talk about interdisciplinarity and transdisciplinarity, this is kind of a project which is working in practice on a very specific issue. So this motivation has been driving, I think, the project team for the last 5 years, and which is also sometimes very new, which can be challenging, but which has produced very concrete results. Yes, so what have we actually done? So from 2019 to 2022, we have been working in the Tapi and Damanganga catchment in Surat and Vapi. And as I mentioned, there was the COVID period, but due to the valiant efforts of our Indian partners, we actually managed to have sampling done over certain periods. And these were also converted into very concrete policy relevant outputs. So there's been 2 strategy reports that were released. There was an informal sector study and also a COVID study, which specifically dealt with Delhi. And this was during the very beginning of the pandemic. And in this very tiny blue box, there's an aggregation of the kind of work that we have done. And it's not so important to know the exact details, but a lot of that information is available to all of you. So you can find it online. And I also welcome you to check out more information from the project web pages. One interesting aspect that we also managed to do, and I was just talking about modeling, is we developed a modeling tool, which is also publicly accessible. And this is specifically related to the transport and fate of microplastics. And this is something that we're trying to translate into the Kaveri basin as well, with both microplastic and macroplastic components. And when we talk to policymakers, this is something which they always highlight. We want visual tools. We want information that we can easily understand. And I think there's been a great interest in this kind of visual tool that in fact also includes a climate model. So you can play around with different indicators and variables to estimate what kind of contamination there might be from microplastics and potentially macroplastics. Yes, and coming now to the second phase. So you can see 2 dots, green marks in the map. So we'll be working full scale in the state of Tamil Nadu together with the Tamil Nadu authorities. And we'll be working also with Uttarakhand on a pilot basis. So in Tamil Nadu, we'll be working along the Kaveri River. And what the Ganges is to the north is really the Kaveri to the south. It's a lifeline. for the entire state of Tamil Nadu. It's very important, very significant, but not so much work done, or actually no work done when it comes to macroplastic pollution in specific, and with some work emerging from the POPs contamination and pollution. And again, coming back to the approach, it's a very kind of multiple approach that involves training of state authorities and the Tamil Nadu State Pollution Control Board. So we had a pilot sampling last September where the Tamil Nadu authorities joined, and which is again something, an emblem of joint collaboration where there's concrete outcomes in terms of training. And it's also really about establishing methods which are adapted to the local context. So a lot of the methodologies, and I'll come back to that when it comes to especially macroplastic measurements, are adapted to, let's say, an European context. It's not adapted for tropical climatic conditions, the morphology of rivers here. And this is something that needs to be harmonized within an Indian setting. And in fact, in December, we have also started to install some passive air samplers in Uttarakhand to measure pollution levels in different hotspots. And this is something that we actually started of course, last year. But next week, we are actually starting a major sampling campaign where a lot of the members here in this team will be traveling down to do sampling around hotspots from Coimbatore to Trichy. So that's something very exciting to look at. So very briefly, and I've mentioned this before, there's the macroplastic and microplastic sampling component. So it's about systematizing collections. It's about systematizing the methodologies. And for instance, I can give you one example of what that means. So for instance, on the bottom left, you can see, a rough sheet, which is used for visual observation of macroplastic data. But this is based on terminologies and products that may be different than they exist in India. So one needs to see what kind of products exist, with what type of design, what type of shape, how they float, and then adapt quantification methodologies for the specific context. So this is basically what we mean when we talk about macroplastic classification for India. I think this will be a first of its kind. And similarly, we are doing the same for microplastics in terms of how methodologies can be improved. How do we sample microplastics in a way that the samples are not contaminated? How can they be best analyzed in labs? And we're working very closely actually with CPIT and SRM on the lab analysis component. And this is also related to the interlaboratory comparison exercises that we have started. And we also hope to receive more of our Indian partners in Norway for different training and exposure exercises. And maybe just very briefly on some case studies. One issue which I think all of you have experienced is the issue of plastic burning, intentional or unintentional, which also releases and spreads microplastics. And this kind of contamination has not been studied too much. So it's important that we look at this. And similarly, also for agricultural plastics, we need to look at some of these issues, which is not studied much. And I'll just be very quick. Professor Paramita will talk a little bit more about persistent organic pollutants later on because of the leachates and the kind of adverse health effects that come from burning or the release of plastics into the environment. And then the final component, and I think this is what makes it a really holistic kind of approach and project, is we can have as much data as we want to. It doesn't make a difference. That data needs to be used, employed, and shared with users who actually apply remedial practices. We know so much about climate change for 20, 30 years. We have lots of data, but translating that into action is a different thing. And this is why the policy and regulatory developments are very key. And also with the INC, and I think Marianne and Her Excellency mentioned the INC earlier, and that's something which we're also trying to connect to with this project. So there's all of these components. I know it's very ambitious, but we are also quite a big project, and I think we are 30 to 40 researchers dedicatedly working on this. So we are very happy to answer any questions from the audience, and I wish and congratulate Paramita and Dr. Grija very much on the book and also the other co-editors. Yes, and looking forward to the panel discussion. So thank you very much. I went a little bit over time.
Thanks, Dr. Hans, for enlightening the gathering on this very important project. Now, I invite all the dignitaries, Ms. Martine, Dr. Girja, Dr. Paromita, Satish ji, and Dr. Hans for the book launch. The title of this book is Managing Persistent Organic Pollutant in India, a case studies on Vapi and Surat, edited by Dr. Paramita Chakravarti, Luca Nizetto, Girja Bharat, Eric Stendel, and Satish Sinha. This book is produced from the research carried out under the INOPOL project. Thank you, everyone. We now have with us Dr. Rachel is a research scientist at NIVA. She specializes in microplastic and agriculture research with a focus on understanding the impact of microplastics on agriculture ecosystem. Today, she'll be presenting on monitoring and harmonization of macroplastics. Rachel, we are glad to have you.
Hello, everyone. Thank you very much for inviting me to speak here. My name is Dr. Rachel Hurley, and I work at the Norwegian Institute for Water Research. I've also been involved in the project since it started in 2019, working on this environmental monitoring of plastics. And today I'm going to focus on one specific part of that, and that's addressing how we monitor riverine macroplastic in India and also beyond. So I'd like to start off by introducing some of the different types of plastic pollution. So first off, we have macroplastic, which refers to the sort of large, tangible, visible pieces of plastic that we often know as plastic litter. We can see here how it looks in the river, and you can already spot some of the sort of common sources of macroplastic litter. So it's the sort of things that we imagine in our daily lives: plastic bottles, plastic bags, these sorts of things. A sort of fairly famous counterpart to this macroplastic is microplastic, which has obviously received a lot of attention. This is because its smaller size increases the potential risk that it can occur on the environment and on sort of human and environmental health. And that's because it's sort of more easily ingested, and it may also transfer chemicals more easily. And of course, monitoring of microplastic is very important, and it's something that we will certainly be doing in the second phase of the INOPOL project, and we also started on it in INOPOL 1. And this monitoring can tell us, for example, the different levels in the environment and start to identify some of the hotspots and where we might actually see some potential hazards. But outside of a few sort of known sources of microplastic, that is these primary microplastics that are made to be small in size, the vast majority of the microplastic that we observe in the environment is actually these kind of fragments, which are hard to actually link to a particular source. And these are actually derived from the breakdown of larger pieces of plastic, our macroplastics. And so it's important for us to monitor these macroplastics as well, so we can actually make a meaningful kind of advancement in reducing microplastic pollution in the environment by turning off one of the important sources of this microplastic that generates these microplastic fragments. It's also important to point out that the INC negotiations that are ongoing in this global plastic treaty, microplastics are not kind of the central component of this. And so macroplastic and the monitoring of macroplastic is also important to consider, as this may be kind of called upon by this new global treaty in terms of environmental monitoring. So already developing some important methods that are well tailored to the Indian environment and also well harmonized internationally is an important advancement towards this potential treaty. And now I'm going to talk a little bit about these different environments. This session relates to the marine environment, and that's also where this the INOPOL project is kind of embedded. But I'm talking today about the rivers, and we've also heard in the early presentations that we are focusing on the rivers. So how does this connect to the marine environment? So, of course, the oceans have received a lot of attention in the context of plastic pollution. And that is because there's been a lot of attention on protecting ocean ecosystems. So we see a lot of entanglement of plastic debris in marine animals. But a lot of this plastic, it comes through the rivers. So all plastic is produced on land, and the majority of plastic is actually consumed and disposed of on land. So it makes a lot of sense to look upstream where these kind of plastics are actually being used and where they generated as plastic waste and leak into the environment. If we monitor in rivers, we can actually get a better spatial and temporal control on the different sources and also the release points into the environment. And this can help us to tailor effective solutions to actually meaningfully reduce plastic pollution in the environment. In addition to this, as you can see in the picture here of this river, there's a lot of plastic that is also staying in the river system. It was previously assumed that a lot of plastic would just eventually end up in the marine environment. There's actually quite a lot of plastic that stays in these river systems and moves around. So if we only monitor in the marine environment, we actually miss some important sources of plastic pollution to the environment. And as well as these sort of ocean animals that we see being affected by plastic, rivers also represent an important ecological zone that also requires to be protected from this plastic pollution. So if we can monitor the plastic in the riverine environments and also meaningfully reduce the pollution there, we can actually reduce the potential impacts to not only the riverine environment, but also the marine environment downstream as well. So in terms of undertaking this monitoring effort, there are a large number of different methods that have been established to identify different components of this macroplastic pollution in rivers. These vary from, for example, visual observations of the river using human analysts or technological solutions such as cameras and drones. There's a variety of physical interception-based techniques, such as the use of nets here, where we can actually intercept the flow of plastic, remove it from the river, count it and categorize it, and also it doubles up as a cleanup effort as well. There's also a lot of approaches to how we kind of quantify this plastic and characterize it so we can understand a little bit more about source dynamics, how long it's been in the river, some of the sort of fate and transport processes. The monitoring data itself can tell us a lot of things about sort of the levels of pollution in the environment, establish some baseline concentrations for macroplastic, but it can also tell us things such as how the plastic moves through the environment as well. But whilst I sort of mentioned these different topics that monitoring can kind of address, it's important to recognize some of the challenges associated with monitoring. So actually to answer some of these questions, to understand kind of the spatial and temporal dynamics of plastic pollution, this requires a lot of resources. So it's a demand on resources. This is in terms of costs, time, personnel. And this is especially the case where we want sort of time series data for building these effective models. The heterogeneity of macroplastic, all these different types of macroplastic we see, different sources, and also the kind of spatial and temporal variabilities that we see in the environment. This means that if we want high quality data, we need to have lots of different monitoring locations and monitoring time points to actually get a control on what's going on. And because of the kind of global diversity of different river environments, they look very different, rivers across the world. There isn't one sort of standard method that we can use and apply in all river systems globally that can actually measure all of the macroplastic in a single measurement. And because of this kind of mosaic of different methods that are emerging, it means that we're sometimes not talking about the same thing. We're reporting macroplastic, but we're reporting it in a different way. And we then can't compare that data. So what is the future here? So because of this diversity of river environments, harmonization is more relevant than standardization in this context. And this refers to adapting the methods so that we can achieve a meaningful level of comparability in the data sets that come out of these. So there's a need to sort of identify, for example, a subset of methods that can be used in different sort of globally relevant river typologies and common adaptations, and make sure that we describe the methods that are undertaken very carefully and report the data in sort of standardized ways so that we can actually compare between different rivers globally. And it's also to point out that these methods should then be feasible within these kind of resource constraints of monitoring. That leads me on to describe just very briefly some aspects related to the river and macroplastic monitoring that we'll be doing in INOPOL. So we will be actually undertaking some quite intense monitoring, and we're going to, in this period, characterize these spatial and temporal variabilities in the macroplastic in the river. This will allow us to identify some important sources and also source dynamics, and then establish a baseline for the pollution levels in the rivers that we're working in. And this has sort of two important outputs. First of all, we can use this high level of characterization to allow future monitoring that carries on sort of beyond the project, to use a simpler and cheaper and easier to deploy method, and use some of this intensive characterization as sort of a proxy to understand the sort of bigger picture, so that there's not a requirement to continue investing in every single river in the world to actually obtain this level of monitoring. So it kind of fits within these kind of providing a meaningful and useful tool for the future. And also this repeat monitoring, using this characterization, can then be a useful measure for actually understanding whether the measures that we are implementing are actually having an impact on reducing plastic pollution in the environment. So that's something that we started in the first phase of the project, and we'll continue in the second phase. And we're looking forward to sharing that with you once we've been able to get out and do some monitoring in the rivers. And that's everything for me. Thank you very much for listening.
Thank you, Rochelle. You touched upon some really important topic and issues related to microplastic monitoring. Now we have with us Dr. Cecile Ranaclave, Senior Research Scientist of NIWA. She has an extensive expertise in aquatic ecosystem. Her research focuses on understanding and mitigating environmental impact, particularly in freshwater environment. She'll be making a presentation on monitoring of persistent organic pollutants in riverine and marine environment. Over to you, Cecile.
Your Excellency, friends, colleagues, and friends of waters, of course, I'm very glad that I can be here today and give you a short presentation of my daily work, actually. I'm working at NIWA, the Norwegian Institute for Water Research, and I'm working in the field of catchment processes, and where we handle POPs from the source and where it's mobile in the environment. So why should we bother about POPs? I know that a lot of you here, you work with plastic, and some of you are maybe not that familiar with POPs. So I will give you a short presentation of POPs, persistent organic pollutants. Why should we bother about these substances? They are, first of all, widely used in our daily life. As you can see to the middle here, the letters in blue that the chemists usually use for these substances: bisphenol A, BPA, which is widely found in plastic bottles, packaging material; DDT, a pesticide, like in Norway, we stopped use in 2017, and today we even find it in huge amount in some areas. TBT, used for biofouling, to prevent biofouling of ships. PBDE, a brominated flame retardant, widely used in textile industry. PFAS, a kind of modern compound that we find today in our kitchen when we make food from non-sticky pans, and we find it in paper that has been coated to prevent it to get wet. And you have PCBs that are, for instance, used in the windows, filled in material in the windows, the ceiling. And we have short-chain chlorinated paraffins that has been replaced by PCB, but are exactly as toxic as the PCB. So why should we bother? Because they are all around us the whole time, and they are toxic. They have different toxic mechanisms. Paramita will maybe tell about that later, but they can be carcinogenic. They are endocrine disrupting. They can affect our nervous system. So they have a lot of toxic effect on human health and also on the environment. They are persistent. As long as you get them, when you get them into the environment, you will never get them out again. Like the pesticide DDT that we stopped used in Norway for 50 years ago, we still find them in high concentration in the environment. And they bioaccumulate, as you see here, with a typical Norwegian food chain. The highest concentration you will find in the polar bear, which is on the top of the food chain. And they are mobile. They move from soil, sediments, to the ocean. And finally, they are transported, long-range transported through air to other countries. So in the North Pole, you have a lot of higher concentration of most of these POPs that I show you here. So why should we bother monitoring of the POPs in the aquatic environment? When we're monitoring POPs, we determine the concentration in biota, for instance, like fish, as shown here. At the picture on the top from India, people are consuming fish, and we also use the water as part of the aquatic ecosystem to monitor the POPs, because a lot of the POPs are mobile and they run through the water out to the sea. And finally, a lot of the POPs, they are also very, very hydrophobic. That means that they're dissolved very easily in fat and can be transported down to the sediments, where they kind of stick and will not be removed. So monitoring is very important to protect human health, but also to protect the aquatic environment. Monitoring will secure water resources for uses and harvest, to make us continue to harvest all the sources that we have from the sea that we are harvesting today. And monitoring is also very important to identify and stop sources. And if you have an aquatic environment with high concentration of POPs, for instance, in the sediment, which is quite common in Norway, then it's very expensive to remove the sediments, and you have to prioritize measures where to remove the sediments. And in Norway, in our national state budget, we have one chapter dealing with removing contaminated sediments and soil and ground. And this is yearly, we have a sum of money that goes to this topic in order to prevent the contaminants going into the aquatic ecosystem. And finally, everything which is produced at land will enter the ocean. So that's why it's very important to monitor the POPs. But I think I think we have to have hope here, because there are ways that we can prevent the contamination of POPs in the aquatic environment. First, we have to stop import of these substances, we have to stop production, and we have to stop the uses. And some of the POPs, they are produced in the industry and unintentionally by processes like dioxins, for instance, that are one of the most toxic POPs that we have. And we have to have strict control of industry and sector using and discharging POPs. That means we have to have strong regulations. Here I show a picture of my colleague Rachel sampling soil in Norway, agricultural soil. We use a lot of plastic in agriculture, and we also use a lot of pesticides. And in this project here, we will look at pesticides in the soil, and also additives added in the plastic, which are POPs. And one important area to remove, aspect where you can remove POPs, is that to have a safe waste handling. And for the POPs, we have 3 very important international conventions. The Stockholm Convention, which is the most important one for POPs. We have the Rotterdam Convention and Basel Convention. And all nations should act accordingly to these international regulations on POPs. And in the INOPOL project, we are helping the Indian nation to improve their national implementation plan for further implementing the Stockholm Convention in India. And of course, it's very important to increase environmental awareness among people, politicians. That will also prevent people from getting that will prevent people to be in contact with POPs. Sorry. And in Norway, we are good at remediation of sediments and contaminated ground, but from the 1980s until today, the Norwegian state has spent 0.1 billion euro or American dollar removing sediments. So Norway is one of the leading nations in sediment remediation and removal of contaminated sediments. So here I will just show you some cases, because we have to have hope. And here is a case from Latvia where NIVA is participating to the left. In this case, we are removing sediments, and you can see in this lower picture here, this is in a canal called Karasta Channel, previously used by the Russian army in the Baltic Sea, and a substantial part of the channel is used for removing of sediment and put the sediments into this deposit. It's a very expensive work, and but that has been done here in Latvia, but also in Norway, several places. And here, well, it's not very well. You can see the, maybe you cannot see it. Here is the Norwegian National Monitoring Program of POPs along the coast of Norway. We have 55 stations where we measure concentration of POPs in cod, which is a commercial important fish in Norway, and it's common use for eating. We measure concentration in a dock, a common eddy, which is a dock that is on threat. And we also measure concentration of POPs in the blue mussel in 54 stations. And blue mussels is also used for consumption, but it's also a species that is not moving around like the cod. And in this program, we also have monitoring of snails, dogwort, and common periwinkle. And in 2008, there was a ban on TBT. TBT has been used to prevent biofouling of ships. And in 2008, it was a ban on TBT, and very low concentration of TBT may result in that male snails turn into female snails. And as a result of that, the population of snails may collapse. And in 2008, there was a ban. And after 9 years, we have no impulse sex observed in the snails along the coast of Norway. So it took 9 years to improve the ecosystem. Finally, here, there's a picture from plot from the Norway largest lake, Lake Mjøsa. It's close to a sea. The deepest point is 450 meters. And upstreams in the lake, we had the textile industry using PBT for stop the textile to take fire. So, and in 2001, that was the first time Norway measured PBDE in Norway. That was the first time in 2001. And in, sorry, it's not visible here, but in the 90s, we had fish in the NIVA has had fish in the freezer from the 90s. And in 2001, we started measuring, and then NIVA found out that the concentration of PBD was among the highest one you ever seen in the world. And in 2003, they had to stop use the substance, the textile industry, and there was a substitution from PBDE to another compound. And today, sorry, it's not very visible here, but after 10 years, you can see that the concentration in the fish was back to background levels. So it took 10 years to get the concentration of fish back to normal levels, background levels of PBT. And previously, we had small commercial fishery in this lake, but still today, there are no one that do the commercial fisheries. Maybe the knowledge had gone, I'm not sure, but today there's no one doing this. So this was some example how we can, we have to have hope. And finally, thank you for your attention. And as you see from the picture here, sampling in Trichy. And on Sunday, we are going on our road trip in Kavri River, as Frans told us. Okay, thank you.
Thank you, Dr. Cecile, for your detailed and informative presentation on a very critical topic of managing POPs. Now we move on to the next session of today's. I'm glad to announce a panel discussion on reducing plastic and chemical waste in the marine environment. We have with us on the chair, Dr. Girja Bharat, Managing Director of Mu Gamma Consultant. Among the panelists, we have Dr. Smita Mohanty, the Director, Head, Principal Scientist, Research Institute of Petrochemical Engineering and Technology. Mr. Satish Sinha, Associate Director of Toxic Link. And Dr. Paramita Chakravarti is the Professor and Head of SRM Institute of Science and Technology.
Thank you, Kriti. It's an honor to chair this panel and be here to discuss what we have been doing so passionately for the last several years. In fact, it took us several, I should say, even if I say it's decade, it's an understatement because it took us 15 years to build this momentum on persistent organic pollutants and plastic waste management, microplastic issues have been there, but we have been ignorant about it. So we have with us very strong panelists. Dr. Smita Mohanty could not join us today. We will be having few questions to each of the panelists, and I'll request everyone to kindly be brief. Thank you so much. Smita, the first question would be yours, since you are from CPET, a leading organization in India on petrochemical engineering and technology. And given the issues of the growing war against plastic, how is the bioplastic industry growing? If it enters the waste stream, how is the recycling impacted? Over to you, Smita. I hope you were able to hear me. Maybe by the time Smita joins, I would request Paramita to answer the question. You have been working with POPs, endocrine disrupting chemicals, and several others for so many years, decades, yeah, on hazardous chemicals. How difficult or easy is it to apportion the effect of one particular class of POPs to a certain disease? Because these are like questions everybody has in mind. So, yeah.
Thank you, Girija. This is a very important question. Like, we are exposed to a cocktail of POPs at the same time. So in order to understand the impact of a particular POPs and connecting it to a disease, we have to go for cell line studies where we do exposure analysis. We expose a compound and see the impact on different cell lines. That is one way to understand it. But at the same time, I would say this, like when we do human monitoring, we tend to understand the body burden, and we try to connect, like, different organs are impacted by different kinds of POPs. There are different receptors which these POPs can bind. And then based on those receptors, like what kind of hormone mimicking might happen, we can target like what disease can come up. So it's quite an elaborative study, and that's how we should be doing it.
Thank you so much, Paramita. Smita, were you able to hear me?
Yes.
Okay.
Yes.
Should I repeat the question or you're good to go?
Yeah. I just got disconnected.
Yeah.
Yeah. Sorry.
So the question regarding bioplastics, since you are working on bioplastics and you have also written a paper on that, and it's still work in progress, I know, but how is it going to impact the waste stream, because we are considering recycling?
Yes. So bioplastics, as you all of you know, that since today, we don't have any Indian, company who really produces those bioplastics. We are still importing from abroad. And so far, whatever has been there in the Indian market is basically through the distributors in the form of carry bags or in the form of all the single.
Yeah. I think Smita's connectivity, some issue there. Okay, you're back.
I hope I am audible.
Yes, you are.
Okay. So the major thing with the bioplastics is that, their functional properties are somewhere less than the conventional plastics. So once it enters the recycling stream, it becomes really difficult. It actually acts as a contaminant for the normal recycling stream. So they need to be treated separately. They need to be collected separately, and they need to be collected along with the garbage so that they can be composted. So that is how it needs to be managed, and its end of life needs to be managed.
Yeah. If we don't have plans for its management, it ends up in the landfill or it gets burnt. So these are both aspects which we are completely against. So how do we prevent that? Because as you mentioned, we are importing. So there has to be a plan of action for managing.
For managing the end of life, alternative is only the composting. And so far, if we see the composting as per our EPR portal, which has been developed, there are 12 to 16 composting units throughout the country. So, and BIS is also in the process of developing a particular color code mechanism for it, so that it becomes really, easy and sustainable practice for all the ULBs and other people who are broadly associated in the field, so that they can collect it separately. The source collection is amicably done, and then it enters into the composting mechanism. And in the composting, it gets converted to carbon dioxide, water, and biomass. So the only one end of the solution is to get them collected separately and dispose of them in the composting sites.
Thank you. But there would be so many practical difficulties in collecting them separately, because visually you can't make out.
No.
Yeah, unless there is some aspects. Maybe Satish ji will throw more light on it when we are talking about the informal sector. Thanks, Smita. Satish ji, you have been working in this sector for several years, several decades, I must say, and been representing India in several of these negotiation meetings. How is the bottom-up approach in tackling plastic pollution being taken care of, for example, in involving local communities in its efforts, and what measures are being taken to empower these communities in the management of plastic in their respective regions?
Managing it from downstream, perhaps that's something that we understand, that anything that happens from downstream upwards is more sustainable in many ways. And that is what is the advantage of doing this kind of strategy and planning for plastics also. But fact remains, it has its limitations, downstream management, or looking at effort from downstream upwards. Some of those efforts can result into significant positivity. Is about, if you're talking about some legacy waste, or you're talking about cleaning up, I think, or if we are attempting to do behavioral change at the community level. Now, if any of these things are achieved, and especially the behavioral change aspect, I think it makes a very, very significant kind of contribution to looking at plastic waste management. But I think the larger issue that I would also like to bring up here is, that is one kind of a solution that you're looking at from grounds upwards. But talking about plastic waste, it's at this point of time, what we all understand is a global pollution. It's not a local kind of pollution that you can deal at a local level. It is a globalized situation. And I think we all understood from the presentation which was made here, how from rivers and streams it moves to oceans, and oceans become a globalized system of pollution. And that is why there are many kinds of efforts that will require is a global effort. No global pollution that I have known so far across has been done by local solutions. Most global pollutants are addressed by global efforts. And in this case also, when we talk about the coming together of 150 countries to manage this, I think that is a global effort that we're talking about as far as plastic waste is concerned. And I think many of us do also think that, it's about just looking at the downstream of plastic waste. looking at the waste management aspect, which is being emphasized in many of the forums that I go or listen to. But the fact remains it requires much more comprehensive understanding of plastic. It will require, solutions both at the demand side and the supply side. It requires a very comprehensive kind of a thing, and also on the waste management side. So it will require a demand side approach. It will require a supply side approach. How do we regulate both of them, or how do we manage both these things, and the waste management aspect? Unless we come up with all these things in a comprehensive manner, it will have limited results as far as looking at plastic waste management person. So that's my limited answer to my own understanding on the subject at this point.
Thanks, Satishji. Smita, over to you now. I hope you are there, Smita. All right. Paramita, given the complexity of water pollution caused by POPs, persistent organic pollutants, and the plastic additives, which you have been working on for several years, how can an integrated approach be implemented to address this issue, considering the involvement of several stakeholders, especially in Indian scenario where the issue of emerging contaminants has still not received full attention, in spite of our work and so much of noise? Yeah. Please.
When it comes to water pollution, first we need to think whether we talk about surface water, river water, or groundwater. In both the cases, I'll just give, before we talk about like what kind of approach we can take, what is basically the source of these contaminants. Also, we need to have an understanding. We talk about industrial source, but then there is also open discharges in the surface water, in the riverine systems, which brings in cocktail of chemicals in the water. And there is also, we have evidence that open burning is another factor that bring in with the monsoonal shower a lot of chemicals into the river bodies. So given this scenario, this different kind of persistent organic pollutants, not just industrial sector, but also in terms of open discharges or open burning runoff, surface runoff, what we say, do come in the system. In this case, like definitely stakeholders from varied sections needs to come together. Like say, for example, we being an academic school, we look into the factor like what is the problem statement, and we try to come up with some sort of a cost-effective solution. In this regard, I'll mention you, we have come up with a very unique solution, which we named as Mantra Pot. It's an integrated approach, which we have a constructed wetland on the top, and in between we have a nanocomposite layering impregnated with indigenous microbes. And this is a kind of system which can be installed near the riverine bodies, where it's very natural. It can self-sustain, not very, very cost-effective. What we do, even after a primary or secondary treatment, this water, before entering the water bodies, can enter through this system. Actually, naturally, it is happening in the wetlands, which unfortunately we are not taking care much. So in this regard, stakeholders from varied sections, be it the academics, government bodies, industries, everybody needs to come together and then understand the fact that whatever water gets into the system, or even in an industrial belt, what is getting into groundwater, it is not just the problem of that area. Even the rich people who are taking that water, they are taking from this groundwater. It's a common source. So it's a problem for all. The entire stakeholder needs to come up. Like what approach I'm telling, there are several other approaches which can be taken up. A very natural based composite materials can be used in a scientific approach. And that's how I think it could be a way out.
Thank you. Thanks, Paramita. That makes sense. Smita, now you're back. I just thought to check with you that addressing plastic pollution requires a system-wide approach.
Sorry. Am I audible, Girija?
You are. Yeah.
Yeah.
So could you hear my question? I was saying, yeah.
No. Okay.
How do you see INOPOL project addressing this? How is it able to
Sorry?
bridge the gap? Addressing plastic pollution
I think
requires a
there is some connection
system-wide.
issues over there.
Okay, okay. But we are able to hear you. There is some issue with the connection. Yeah. Okay. Satishji, in the meantime, I will request you to discuss about the INC. Yeah, so you have been, as I mentioned in my introduction, you have been part of this INC negotiation and the complexities of arriving at a treaty you are quite aware of. Just enlighten us.
Thank you, but I haven't been part of the plastic INC, but I have done many other INCs and global negotiations. So I understand that dynamics a little bit, but we have been as an organization participating in the INC of plastic also. And my colleagues have been going there and I've been following it very, very closely. So as we all know that we have had 3 rounds of discussion now, and the process that we follow is that you go through the whole thing and every country has their own positions on the issue. And there are some basic norms that you try and address in this convention. So like if I say that, what are you trying to achieve by this convention? So you're looking at, if there's plastic production, how much to produce, what can be targets, what are the goals? If plastic trade has to be managed, how do you manage the trade of plastic waste and plastics? So then are there goals which are going to be nationally specific goals or global goals? Or are there going to be some reduction in trade or in quality control or the kind of chemicals that you're using in it? So these are things that actually get discussed in this INC. And this is what has been happening in the last 3 meetings that we've had in Uruguay, Paris, and Nairobi. So they have a 0 draft at this point of time, but the negotiations that have happened so far in all these meetings have largely been focused on, in many ways, most countries do realize that chemicals is an issue. This was not so earlier, but now I think after the 3 meetings, there is a common understanding that yes, chemicals is a problem and you need to deal with chemicals. But the focus on many of these countries is also how much can you do about these chemicals? Chemicals can be dealt with in chemicals treaties. Why does it have to be dealt in the plastic treaty? So that's another argument which is being made in many of these things. But the other aspect is that how do countries are positioned in many of these things? If you look at India's own position in the INC, all the 3 INCs that we have had, it's been more from the perspective of, can we manage the waste that we generate from plastic? That is the most formidable kind of a stance that is there. So similarly, if you look at countries like China, India, Russia, they all are, and many of these oil-producing nations, like the Middle East and all the countries that are basically the raw material, the source of plastic is there. So many of these countries are essentially trying to push for the downstream management of plastic. Because many of us also mistake by saying that it's more of a downstream issue. If you manage the plastics well, I think we have solved the problem, which may not be true. I think the problem is more about the chemicals part of it, and which nations will take time to come to terms and start to say that, how do we reduce chemicals? The other aspect of it is about, when I mentioned this, supply side and the demand side. Now, demand side can be managed because if you control industries and markets of the production system of consumption of this, maybe you are able to reduce by 10%, 15%, or 12% as nations agree. But the supply side of plastic is also very, very important. Who are the manufacturers? Where is the raw material? How much of sourcing is done? So are you willing to take a cut there? So is the supply side going to be impacted because of this? Now, that's a very important kind of debate that is going to happen. And that's the negotiation, which will take some more effort to try and get there. So there are various countries which have different positions, but largely what we have found in the last 3 meetings is about a large focus is on waste management and a couple of tools that you have on waste management to do with it. But I think the other kinds of things about design, about chemicals, about regulation, about restriction on manufacturing, all that become very, very critical. So that's the kind of stance that is there. And I hope Canada proves to be a place where we are able to negotiate harder and better. I think it is how do we negotiate this for the common good of the world today, and that is the most critical thing. Thank you.
Thank you. Thank you, Satishji. That was very apt answer, and we were all looking forward to that. Yeah, the Intergovernmental Negotiation Committee, the INC, has been very active, and Norway is great part of this whole process. And I'm glad that we are there in some way or the other associated with it. And if Smita, you are there, may I give the last question to you? No. We are actually running short of time, so we have to wind up. So before we wind up, one last question to you, Paramita. This is about the health impacts of this endocrine disrupting chemicals and persistent organic pollutants. And considering that we have limited data, in spite of generating so much of data, and there are several research gaps, so that the policymakers are not able to take it forward for policy recommendations and take it to the society. How do you think we can bridge that?
Yeah, there is too much of data gap from our country, I think, as South Asia as a whole. What we more have environmental data, abiotic matrices, but many of these POPs are mostly lipophilic, so it is more there in the lipid of the body. Mother's milk, breast milk, can accumulate good quantity of POPs. We have very limited papers or data on this. So if we want to do health impact, and if we want to understand POPs better, because when it impacts health, then only certain decisions are being taken. So it's very, very essential for us to start working like not only the abiotic matrices and modeling and understanding the fate of these molecules, but how human health can be impacted. Also, what we are doing in INOPOL project, I must mention that we have also done bovine milk, the cow milk, the grazing in this, hotspot areas, and how this bovine milk can be a source of this POPs and can impact human health, that we have taken up. But in the long run, we need to work on more on the human breast milk and the placental transport. That's what actually we are initiating now, like how from, during the childbirth, from placenta to the next progeny. This kind of data is very much needed to understand the health impact of these contaminants.
Thank you, Paramita. So that brings us to the close of this panel discussion, and I would request Nathaniel, my colleague Nathaniel, to take a few questions. Over to you.
So we're going to take a few questions. Just raise your hand. My colleagues will help that. We have a couple of hands there, Manisha. On the side. The gentleman in the red tie and the lady next to him. Please introduce yourself, your question.
I'm Kumaresh Mishra, and I'm director at the Indian Chemical Council. It's a representative body of all the major chemical and plastic manufacturers, petrochemical manufacturers in the country. And one of the challenges that we find, and of course, Mr. Sinha referred to that, was in terms of taking a holistic view, systematic view, looking at the demand side and also looking at the supply side. And one of the things that we do need to come up is in terms of a dialogue. Now, in terms of the project that also has been presented here, we've looked at the visible aspects of plastic pollution everywhere. So everyone gets concerned. Of course, there are many invisible aspects like the POPs. So how do you bring the other players in terms of the discussion? That is something that we need to think about. And I don't know if you have any ideas, Mr. Sinha, and others, that we need to bring other parties, the supply side, who are equally keen. Just to let you know that in 2019, when this project started, the same year, Indian Chemical Council and all the chemical companies decided to have a sustainability conclave. So it was 2019 that we started in collaboration with UNEP and International Council of Chemical Associations, ICCA, as well as CEFIC and American Chemistry Council, to focus on chemical sustainability, to have sustainability by design, by having, whenever you make a product and when you use it, you can do it. So it's a suggestion and a question that how to bring the supply siders also onto the discussion table in the project and beyond it. Thank you.
Thank you. Who is the question directed to? We have the, would you like to take it, Mr. Satish ji?
Sorry, I completely support your question and I'm for it. Yes, we need more conversation around this. Let me say this to you that till about 7-8 years back, we were not having this conversation about chemicals in plastic. We only treated plastic as a material which was non-biodegradable and which accumulated on this planet. We didn't have even an iota of information or evidence about microplastics presence in human body or in food chain. So these are all new things that are emerging today. And we have much more formidable data on many of these subjects. So the question is that you have about 10,000 chemicals in plastics. And I think the chemicals industry, along with the plastic industry, need to sit together with other kind of downstream users who are using this plastics product. And I would just like to add one more thing. Microplastics is not only secondary microplastics, it is also primary microplastics, which you use in your toothpaste, which you use in your face scrubs, these are all intentionally added to the products to give you the kind of this thing that you want property from it. So I think we need to come together, sit together, find ways to deal with it. Are we ready to substitute some of these chemicals? Do we have these chemicals which can be substituted? I found in my own little experience that I'm talking about in the last 5-7 years, when we talked about bisphenol A in feeding bottles in India, it was there. Bisphenol A was there in the feeding bottle for children. The industry came forward and removed it. So there is possibility of doing it. I think we need both voluntary action, regulations, and approaches and negotiation of this kind. So I think all of it is open. And I think the larger part that we're talking about is human health and the environmental health and marine pollution. I think we're talking about all these things. So it is important for all of us to come together, but I see huge hope and possibility in removing many of these things. It's possible to do it. Thank you.
Thank you. In fact, this question is so interesting that there may be many more further questions beyond this. So I would request that you could connect with Satish ji separately after the session. Thank you so much. We have time for just one more question because we have one more.
Your name, introduction, and a very quick question, please.
Good afternoon, everybody. My name is Ridhima Kaul, and I'm an international maritime lawyer with the National Maritime Foundation in New Delhi. So initially, a lot of people were talking about the upcoming plastic treaty. Just wanted to mention that the recent BBNJ treaty has also now talked about plastics. Earlier, it was only MARPOL who was discussing about plastics, but now it's BBNJ. A second that I wanted to say that the plastic treaty is going to take some time to get formulated. And I think countries like India just can't be sitting and doing nothing about it. And I think that we should now enter into multilateral environment agreements as well with different countries, Norway being one. Second, that I just wanted to say, and I think Satishji has also mentioned this, and a lot of people, involvement of industries who are manufacturing plastics is very important. What are their roles, and how can they influence reduction of plastics is something that needs to be discussed. If this is not done, I think the plastic treaty is going to be a very soft law that will have a lot of loopholes, and I think the intent to reduce marine pollution will be lost. That's it. Thank you.
It's very important to hear the perspectives of a lawyer, and I'm glad that lawyers are also taking interest in this. Thank you so much. I'm sorry we are unable to take more questions, though we would have wanted to, and we are available. In fact, we have a half-an-hour break after this. We will definitely be able to answer whatever questions you have, and if we can. Thank you so much. Thanks, Paramita. Thank you, Smita. Sorry for the poor connectivity, but still, yeah, you gave that answer, the first one. That was very interesting. Thanks for that. Thank you, Satishji. Yeah. Now, I would request Dr. Saloni Goel to please come over and give her perspectives. We have been discussing a lot about informal sector, and several of our colleagues are working in this area of informal waste management workers. And Dr. Saloni Goel has been an exemplary professional who has worked with UNEP, who has worked with Niti Aayog. She's from IIT Delhi, and then vast experience in the sector. Now she's the director of Realign, New Delhi. Over to you, Saloni. Thank you.
So please allow me to congratulate the government of Norway for consistently supporting scientific research on plastic pollution, including marine plastic litter, and in building capacities in India for this research. I am deeply indebted to Dr. Girija Bharat, who continues to keep me engaged on this subject. It's a subject that's very dear to my heart. I worked on circular economy and different aspects of waste management, including plastic pollution and plastic waste management. Having said that, I recently joined the corporate sector, the financial services sector, and in some ways I'm here as a representation that these two spaces actually need to be straddled. It is my firm belief that going forward, forums like this need to engage and invite even the private sector to come and not only understand the space, the challenges, the priorities, and also start increasingly adopting them and running with them and contributing to them constructively. So from that perspective, but I'll start with what I think, and I'd just like to bring a kind of a disruptive approach to working with waste workers. And this I'm drawing from my experience of working on sanitation at the world's largest mass gathering. This happened in 2019. 240 million visitors gathered at the confluence of three rivers at an event that is widely and known worldwide, the Kumbh of 2019, which was organized at Prayagraj. I was leading the sanitation work out there. And on the peak bathing day, that's the day when we witnessed 40 million visitors at the venue at this event. One waste worker walked up to me and he said that I'm very happy working at the Kumbh this time because this is the first time I haven't had to touch waste. I have not had to encounter rotting waste or ever come in contact with waste. I'm using that as an example or a very strong testimonial to bring to your attention that the waste worker wants better for himself. I believe that the argument that we need to continue engaging waste workers in the whole process of waste management, I think that argument now needs, or that conversation needs to be widened. We need to think about how we can empower waste workers. We need to think about improving their working conditions as waste workers. which could be a combination of better equipment, greater automation, use of innovative technologies. But I would also like to urge this August gathering to think about, can we actually push and drive upskilling for waste workers and actually help them graduate to the higher up the food chain. And I think that's where initiatives and progressive countries like Norway also need to lend their weight, whether it is in their initiatives at bilateral level, but also at multilateral levels at the INC. How can we create conditions, both from a pull as well as a push perspective? How can we push waste workers out of this area of work? And in doing so, I'm actually looking at just transition in a slightly disruptive way or a slightly unconventional way, that let's not wait for disruptions to push waste workers out of this or to help them make a transition. Let us help waste workers make a transition and therefore push the sector to come up with disruptive innovations and technologies so that the whole waste management process can be done with less drudgery, maybe in a more mechanized way and a more efficient way. That is one point that I'd like to leave you with. The other thing that I would like to also bring to your attention, and because now I'm working in the financial space, is that I think we're all seeing a gradual erosion of funding for the development sector. While if the development sector or development initiatives have to be carried forward, of course, we understand we need funds for that, but we're also understanding that funds are not coming easily. And why they're not coming, what needs to be done. And despite all the repeated initiatives or efforts or pushes at the national, subnational, bilateral and multilateral levels, global levels, we're still not being able to mobilize the required fund. The gap between what is required to achieve maybe our climate objectives or maybe our waste management objectives, that gap is only getting wider and wider. It's just becoming a more and more yawning gap. So how are we to actually create a sustainable pipeline of finance for this sector, for the development sector as a whole, but I would even say the waste management sector, the circular economy sector. I would like to look at it from two perspectives, both from the financer side as well as from the recipient side. I think from the financing side, we need to start looking at creative financial instruments which will allow cheap finance to flow to this sector. There is only so much of this sector or activities of this sector, noble as they are, can be supported by grant. We will have to find or provide access to affordable capital for this sector. And I think that's where we need to widen our engagement pool, or widen our engagement with various resources in the economy and say, push and drive everybody to look at finance from a creative point of view. I believe a big impact can be made by reducing the risk perception of this sector. And there are several instruments that are already being deliberated, and they are predicated on risk pooling, risk reduction, risk mitigation, but they're only the start. And certainly this gathering needs to put its weight behind this conversation. The other thing that I would also again like to suggest out here, take that liberty, is how do we also incentivize or encourage the various waste management agencies across the country, which could be, they could be agencies that are working, that are being operated by the lowest rung of the waste pickers, it could be aggregators, it could be various waste recyclers. How do we also try to bring in greater financial literacy, and how do we push them to think of this as developing it into a business, as a viable financially viable business? Because I think, and this is, I'm drawing from my experience of working with the private sector as head of circular economy at UNDP. The conversation or the question that kept coming back to us was, how are we going to make the material recovery facilities financially viable? If we are to bring in private sector finance, and I think that's a trend that is only, that's an inevitability, then how are we going to drive our waste management agencies and waste management initiatives to become financially viable entities in their own right? So thank you so much for providing this opportunity. Thank you.
With that, we close. We would like to thank our guests. Thank you for coming. Please join us for tea. We are also going to have to move quite quickly for the next session that starts at 4. Please keep in touch with us. If you have any questions to be asked, we'll be around. And we're also on LinkedIn, so you can message us. Thank you so much.
निकलने का टाइम हो गया